Hey guys, so this morning we're talking about infinite geometric series. So first off, you need to know that an infinite geometric series is just what it sounds like. It's a geometric series that has an infinite number of terms. And there's two types, there's convergent and divergent. What's important to know about them is how they differ. So a convergent series has a sum, where a divergent series does not have a sum. And that comes from this list of kind of how they work. So for convergent, it has a sum because it approaches a finite value, where for divergent, it doesn't have a sum because the number just keeps getting bigger and bigger. So basically infinity would be the end, so there's not an end. So you can't add that together if it just keeps going. So some little things to help. The R, the common ratio. If it's less than 1, again, don't worry about the sign, that's why it's absolute value. But if it's less than 1, that would mean that it's convergent, where if it's equal to 1 or greater than 1, it's divergent. And so then I just listed an example of each. So like for convergent, those numbers are getting smaller. That's another hint. Where divergent, the numbers are getting larger. So that's the difference between convergent and divergent. Okay, so for our first example, our job is to decide if it's convergent or divergent. And to do that, we're just going to find the common ratio, and that's going to help us to know if it's convergent or divergent. These are geometric series, but you don't always know that ahead of time, so we are going to prove it by finding that R. Again, another way, like if you look up here, is just to tell if it's getting bigger or smaller. So you can kind of tell already, but I want to show you the right way to do it, just in case you did not know if it was geometric or not at the beginning of the problem. So what we need to do for A is, our first number is 2, our second number is 3. So you take your second number, 3, and you divide that by the first. So 3 divided by 2 is 1.5. So our R is 1.5, and you can check that. So you would just say 2 times 1.5, 3 times 1.5, 4.5. So we know that that is right. So then if R is 1.5, that means it is greater than 1. So this is a divergent, and that would be your answer. Divergent. Again, the reason we're telling these apart is so that we know if we can actually find the sum or not in our later questions. So for our second series, we have 150 and 25. So again, you take that second number, so 50, divided by the first number, 100, and we get 0.5. So our R is 0.5 or 0.5. So again, that would be less than 1, so that should be convergent. Let's just double check our work and make sure it works. So 100 times 0.5 is 50, times 0.5 is 25. So yes, that was the R, it is geometric. And again, we would say this is convergent because the R is less than 1. Okay, so now we're going to find the sum of these infinite series, so we have to have that sum formula. So it's a little bit easier than our last sum formula. So it's just the sum is the first term over 1 minus the common ratio. So one thing to know is, remember, if it is convergent, it has a sum. If it's divergent, it does not have a sum. So we still need to answer that question first. So I'm going to go ahead and put the calculator here so you can see this, okay? So with A, we have 4, -2, 1, -0.5. So you take that second number, which is -2, and divide it by the first, which is 4, and we get -0.5. So we're saying that our R is -0.5. And again, we can test that. 4 times -0.5 is -2, times -0.5 is 1, times -0.5 is -0.5. So we know that's the R. And then our A1 is 4. So our sum formula, I've kind of blocked it here, but it's A1 over 1 minus R. So you take A1 and that goes on the top. Our A1 is 4 over 1 minus -0.5. So that'd be plus positive. So 1 plus 0.5 is just 1.5. And then we take 4 divided by 1.5. And so our sum is 2.6 repeating. Now, if you want to write a decimal, that's fine. Or you can do math enter and get a fraction. So either of those answers would be fine. There's really not a right or wrong way to do it. It's just your preference. So I think I'm going to do 8 over 3 just to show that it, so I don't have to show that repeating decimal. So my sum is 8 over 3. For our second one, let me clear this out. We have 16, 20, and 25. So we take the second number, 20, divided by the first number, 16. So our R is 1.25. Now, I already knew the answer, so I didn't stop before to talk about this part. So let me do it with this one specifically. If R is 1.25, that means it's divergent and it has no sum. So my answer is no sum. Now I want to show you this because the math would still work. So you need to understand that you have to tell the difference before you start the problem, because if I did my first term, 16, divide, well, I'll do it as a fraction to show you. 16 over 1 minus 1.25, I'm still going to get an answer. But that sum is a negative number, and that doesn't really make sense when we're adding all positive numbers. So you might catch it with that answer, but you just need to get really confident in divergent versus convergent so that before you even get to this step, you can be like, oh, that one's convergent, I can keep going. This one, divergent, okay, stop, no sum. So it just depends on where you want to, like where your comfort level is, but that's how you would tell them apart. So again, this one was convergent, so it had a sum. This one's divergent, so it has no sum, because again, it's just going towards infinity. We can't actually add that up. Okay, so for our last example, we're going to write a repeating decimal as a fraction. This is one of my favorite things to show and teach in class, just because it's really just a creative way to do math that you probably have never done before. You know, we just give those repeating decimals and write them down. So I have a trick that I'll tell you after we work this out, but it is actually kind of fun for those of you who like math. So what you do first is you look at how many numbers are repeating. So we have 0.21, and that bar is over 21. So the 2 and the 1 are repeating. So what that means is it's just 0.212121, like that, and it would just keep going. So this 21 represents 21 over 100, where the next one would be 0021, so just 21 over, and instead of 100, that would be 4 numbers now, so that would be over 10,000, and then it would just keep going. Now, what this means is that this right here is your A1. So remember, our sum is A1 over 1 minus R. So without rewriting it, the 21 over, again, however many numbers, that's how many zeros you need. So 21 over 100 is my A1. So I have 21 over 100 over 1 minus. And then the R, what is the common ratio? So you could do 20, we get a fraction. 21 over 10,000 divided by 21 over 100, and you get 0.01, which is 1 over 100. Now, here's the easy part. It's just 1 over whatever this number on the bottom was. So if this had 3 numbers and that was 1,000, that would be 1,000, so would this. So 1 over 100. These will match, okay? From there, you can type that into your calculator, but again, I want to show you by hand how to do this just because it's really cool to be able to do it by hand. So 1 would just be, I like to do it like this, 100 over 100, because that is 1. So then this would be 21 over 100 over 100 minus 1 is 99 over 100. And then you could do my little box trick. And so you'd have 21 times 100 on the top, 100 times 99 on the bottom. The 100s cancel, and so your answer is 21 over 99. Now, one thing here is this is normally your answer, but if it will reduce, you should reduce it. And we know that both of these numbers divide by 3. 21 divided by 3 is 7. 99 divided by 3 is 33. So 7 over 33 is the fraction that gets you 0.21 repeating. So if you type in 7 over 33, you'll see it's 0.21 repeating. Now, here's my trick that makes it so much easier. All you have to do is however many numbers are repeating, put it over that many 9s. So 21, that's 2 different digits. So you would say 21 over 99, which is what we got right there. And then the only thing you would ever have to do is reduce if you need to. So let me show you another one. Let's say that we had 0.371 repeating, just so I can show you with a different number. So I can go ahead and skip ahead. No, 371, that's 3 numbers. So for my final answer, I would have 371 over, and then that many 9s. 9, 9, 9. And then we just need to see if it's going to reduce. So 371 over 999, you'll see that's got 371 repeating. And then push math, enter, enter, and it doesn't reduce. So that would be my answer right there. So that's the trick of doing it faster, and I'm perfectly fine if you want to do it that way. I just love to teach this so you can kind of see how the math works behind it.